Well, hey there, kiddos, and welcome to your video on simplifying polynomials. It says simplifying monomials at the top. We're going to do definitions later when we start talking about the different things, but a monomial is just the expressions that we've been dealing with all along. This 2x squared y to the fifth, that constitutes a monomial. So does 3x squared. So we're just going to review our exponent rules. I'm going to do 3, maybe 4 examples, and then that's all. And so the way that your your paper is set up, there is a we do and a you do. I'm only going to do the we do side, so you're only going to see the odd numbered problems. If you want to go try one, the we do parts are very similar. So like number 2 is similar to number 1. So if you need more practice, feel free to do that. So let's start with number 1 here. We're just going to review our exponent rules. So I've got this 2x squared y to the fifth all to the third times 3x squared all to the negative 2. And so the first thing we have to do is simplify each set of parentheses by distributing the exponent outside to everything. So this first set of parentheses becomes 2 to the third because I have to distribute it even to the coefficient. Then it becomes x to the 6th, y to the 15th, because I will multiply my exponents then. We'll keep this in parentheses. This set of, this set of parentheses, I'm going to distribute this negative 2, so it's going to become 3 to the negative 2 over x to the negative 4. Now, I'm going to go ahead and take this entire term. I'm going to take all of this because it's all negative, and I'm going to go ahead and drop it down into the numerator or denominator. And when I do that, I'm going to go ahead and simplify what I still have, because 2 to the third becomes 8. So then I have 8x to the 6th, y to the 15th in the numerator. Then down here in the denominator, I'm going to drop this, so this becomes 3 to the positive 2. So 3 squared is 9, and then that becomes x to the 4th. And I'm going to simplify from here using division rules. Well, 8 over 9 does not simplify, nor does it divide, so I'm going to leave that as 8 over 9. And then I'm going to take care of my bases. So I got x to the 6th divided by x to the 4th, which means I will subtract these two exponents. So 6 minus 4 makes x squared. And the y to the 15th just stays put because there's nothing to divide it with. So this becomes your final answer. So let's take a look at number 3. Number 3 is just a straight up multiplication problem. I'm just going to multiply this term times this term. So I'm going to multiply coefficients, add exponents. So 6 times negative 3 is negative 18. When I do a squared times a, remember there's that invisible 1, so it becomes a to the third. And this b times b to the third, again with the invisible 1, you end up with b to the 4th. Done, simplified, that's all there is to it. So number 5, now I've got a fraction or a division kind of problem with the exponent outside. So I've got to distribute this exponent to everything. So I end up with 5 to the third power, x to the third power, over y to the 6th power, because I have to distribute this 3 to every single piece. Well, 5 to the third power, if I use my calculator and figure out what that is, I get that it's 125. So this is going to simplify to 125 x to the third over y to the 6th. So now number 7, I'm going to let you look at it and let it sink in for just a minute and see if you can figure out the answer, and then I will write down what the answer really is, because number 7 looks complicated, but it's really very simple. So if you look at it, you should see you've got this negative 7nm squared to the negative 3 power, all of that to the power of 0. Well, all of it's to the power of 0, so this just equals 1. Because the whole thing's to the power of 0. Anything to the power of 0 is 1. So let's do one more example. We'll do 2 more. And then we'll stop and we'll work on this tomorrow when you come. So this one right here, I've got a rational exponent I've got to the 1/2 power. So I've got to distribute that to everything. So this becomes 4 to the 1/2 power, x to the 3/2 power, and y to the 12/2 power, and then I'll simplify what I have. Well, remember, 4 to the 1/2 power is just like saying square root of 4, which happens to be 2. 3/2 does not simplify, so I still have x to the 3/2 power. And then y, well, 12 divided by 2 happens to be 6, so it's y to the 6th. And if you look at number 11, now I've got all kinds of things happening. So this first set of parentheses, I've got to distribute the 2 to everything. So I'm going to end up with 5 squared, which is 25, x squared over y squared. So I've distributed that little squared to every piece inside, and that is times y to the third over 10x squared. So I have to multiply these together. Okay, well there's nothing, so what I'm really going to do is just sort of put them together, because there's nothing at the moment that I can divide, but there will be if I put them together. So I'm going to go ahead and put these together. So I'm going to write this as 25x squared y to the third, because that's what would happen if I multiplied them. And down here in the bottom, I'm going to put it so it's in the same order. So I'm going to do the 10x squared y squared. Now I have to simplify this by dividing. Well, 25 over 10, I could divide both of those by 5, and that becomes 5 over 2. Then I will simplify my exponents. Well, the x squareds cancel each other out, so there won't be any x squareds. But when I do the y, I subtract my exponents, and it just becomes y. So I end up with 5y over 2. That's my simplified answer. So there is just a review of exponent rules. We've put them all together. We've practiced them all at once. We will continue practicing this tomorrow. You remember you have a quiz Friday, so this makes a real good review. I will see you guys tomorrow.